Hello everyone, myself Manasa. Here are my team members Bindu, Bhavana, Tinchana and Divashri. In this video, we are going to explain this code we to predict the customer spending category using machine learning algorithms. Here we have used three algorithms: KNN, decision tree and naive bayes algorithms. KNN algorithm is a simple and widely used supervised learning algorithm for classification and regression tasks. It works on the principle of similarity, meaning that data points with similar features are likely to belong to the same category. Next, decision tree algorithm. It is also a supervised machine learning algorithm used for both classification and regression tasks. It works by recursively splitting the dataset into subsets based on feature values, forming a tree-like structure. Next, naive bayes algorithm. It is a probabilistic classifier based on Bayes' theorem and the assumption that all features are independent. It is widely used in text classification, spam detection, sentiment analysis, and other applications. This is the code we have used. First, importing the libraries. Import pandas as PD. This is used for handling and manipulating datasets. From sklearn.preprocessing, import label encoder, standard scalar. Label encoder encodes the categorical labels as numeric values. Standard scalar standardizes features by scaling them to have zero mean and unit variance. From sklearn model selection, import train test split. Train test split. This splits data set into training and testing sets. Next, from sklearn.neighbors, import kneighbors classifier. Kneighbors classifier. This implements the k nearest neighbors algorithm. From sklearn.tree, import decision tree classifier. Decision tree classifier implements a decision tree classifier. From sklearn.naivebayes, import Gaussian NB. A Gaussian NB, this implements a naive bayes classifier. From sklearn metrics, import accuracy score classification report. The accuracy score and classification report evaluates model's performance. Further code will be explained by Bhavana.
Load data sets. DF is equal to PD dot read CSV mol customer CSV. It means load the data set mol customer CSV into a pandas for data frame. DF is equal to DF dot drop column customizer ID. Drop the customizer ID column as it is not need for the clarification. Next, encoding genre column label encoders is equal to label encoders. DF genre is equal to label encoder fit transform DF genre. It means encode the genre column which containing categoric values and male or female into numeric value 0 and 1. Next, we'll explain Sinchana.
Next, we have the selecting the relevant columns where DF is equal to DF genera, age, annual income, which is denoted by K dollar, and spending scores 1 to 100. This selects only relevant columns for the classification, and DF is called as data sets. And next, we have the standardizing the data where scalar is equal to standard scalar, DF of age, annual income, spending score, and scalar.fit transform DF age, annual income, and spending score 1 to 100, where this standardized the age, annual income that is denoted by K dollar, and spending score 1 to 100 columns using standard scalar, making them comparable in scales. So next will be continued by Bindu.
Next, we have the splitting the data into a training and testing data. X is equal to def drop column genera. The def is the data set is stored where the genera is the target value. X variable contains all feature except the genera. Y is equal to def genera. X train, X text, Y train, y test is equal to train text split xy test is size is equal to 0.2, random state is equal to 42. The data set is split into a training 80% and the testing is 20% set using the training test splits. Next, we move on to the KNN classification. KNN is equal to K neighbors classifiers, N neighbors is equal to 5. Creating the KNN classifier with a K is equal to 5, meaning it consider the 5 nearest neighbors for classification. KNN fit is equal to X train and Y train. Fits the classifier on the training data X train and Y train. Y predict KNN is equal to KNN predict X text. The training model predict the labels for the test sets X text. Print KNN classifier reporters, classification reporters X text, Y predict KNN. Generated details, evaluations, precision, recalls, and F1 score. Print KNN accuracy score, Y text and Y predict KNN is equal to F4. Calculate and print the overall accuracy. Next, we'll continue by Divya.
Here comes the Navier plus classifier. So now coming to the Navier plus classifier, NB is equals to Gaussian NB, which is the initializes the Navier plus initializes the Navier base classifier. NB fit X underscore train, comma Y underscore rate. It predicts on the training data set, and it Y underscore predi underscore NB is equals to NB dot predict X underscore test, which is predicts the model on the testing data set. Now it prints the NB and Navier based classification report on the testing data set. And it prints the classification report of the Navier base and predicts the accuracy on the testing data set. Now comes the decision tree classifier. It is DT is equals to decision tree classifier and criterion is equals to entropy, comma random underscore state is equals to 42. It prints on the taking the criterion as an entropy and which is predicts on the training data set. And Y underscore predicts dot DT is equals to DT dot predict X underscore test. It predicts the model on the testing data set and prints the decision tree classification report on the testing data set, and it prints the accuracy and the prediction on the classification report of the decision tree. Now I'm going to show the output of this code. So here is the output, which is the expected output format. For each classifier, the code prints the classification report, which includes the precision, recall, F1 score, and support for each class, and the 0 and 1 corresponding to the male and female. The accuracy 4 for the overall accuracy of the model. Example output. So sample output assuming a hypothetical dataset split. So KNN neighbors, KNN output classification report is the precision, recall, F1 score, and support. So the overall accuracy of this report is the 0.82 in the F1 score and support 40, and the overall accuracy is 0.8200. Now the Navier base output. Here comes the Navier base output. The Navier base classification report, which is precision, recall, F1 score, and report. So this is the output, and the overall Navier base accuracy is 0.7700. And now comes the decision tree output. So here is the decision tree output, which is a precision, recall, F1 score, and output. So the overall accuracy of the decision tree is 0.800. So the overall output of this classification report is KNN has the highest accuracy 82% and the Navier base as a slightly worse 77%. Decision tree falls between the two, that is the 80%. So this is our small code which is we have implemented. So thank you for giving us this opportunity to our course coordinator Shivaranjini ma'am. Thank you one and all.